So we have got, okay, a line passing through this point A, which is 302, has this vector equation. So we have got the line there. So it meets the plane pi, which has equation, which is r dot 121 is equal to 3 at the point P. So find the coordinate of the P. So basically, this is not something that is very complicated. It's for us to find the intersection. So in this case, for our intersections there, it is okay, we can actually substitute the equation of the line. So this is our equation of the line. We could actually write it in a single column matrix, column vectors first. Okay, so later on with this equation of the plane here, right, we could just sub in, okay, the equation of the line there. So what is our aim here is to find the value of the lambda that gives us that point P here. So later on, it is just substitute this lambda equals to -1 here inside the equation of the line. So once we actually substitute that in, then we will actually have got this is the point P. Okay, so for the another one, okay, write down a vector n, okay, which is perpendicular to pi, okay, and calculate the vector w, where the w is n cross the 2, 1, -2. Okay, so vector n perpendicular to the plane is basically we have got the normal of the plane. Okay, so the from the equation of the plane that we would have already like obtained this. So the next one is, okay, we have got the w. So we just need to do a little bit of the cross product here. So we use the n to actually cross with like the 2, 1, -2. So we actually get the value of the w here is -5, 4, -3. Okay. So for the third part here, so a point Q, okay, lies in pi and is the foot of the perpendicular from A to pi. Use vector W to determine the equation of a line PQ in the form of R is equal to U plus mu V. Okay. So what happened in this case is actually that, okay, we see here, the situation is something like this. Let's say we have got a plane. Okay, this is our plane pi. And okay, our situation here is that we have got the point A. So the point A is actually what the line passes through, right? And they intersect at the point P there. So let's say this is our line. Okay, this is our line. And then it will actually intersect at a point P, and then it has got some point which is like a point A here, let's say. Okay, this is the situation that we have just now. So now what we have is that, okay, this is a point Q. Point Q is in the plane, and it is actually the perpendicular foot from the A to the P here. Okay, so this is the situation that we get for the point Q there. So what do we need to do in this case is that we want to find a vector. We need to use a vector W to determine the equation of the line PQ in this form here. So what happens is that, okay, what was the reason that they actually asked us to do the thing just now? So the W cross that whatsoever, the 2, 1, -2 here. So we can notice that this is actually the direction of the line. Okay, so what do we actually get when we actually have got this W is that, okay, I'll just roughly show you, yeah. This is the direction of the line, 2, 1, -2, and let's say this is our N. Okay, so as we actually cross it, we are actually getting a vector which is perpendicular to both the N and also the 2, 1, -2 here. Okay, so that vector could be something that is parallel to the plane. Okay, so it is parallel to the plane, but it is not in the direction of this PQ here. Okay, so you see, the what we actually get for this case is that, okay, the N here with something like this. This N is a normal, yeah, but this W here is actually parallel to the plane. Okay, this W is parallel to the plane here. So now we want to find the direction of the PQ. So if you want to find the direction of the PQ, it is that we are crossing the W with the N again. So crossing the W with the N in this case here, right, will give us a vector that is perpendicular to both the N and the W. Because if we actually cross the 2, 1, -2 and the N just now, right, when we do this, right, we are actually getting like a W here. So this W is actually sort of like perpendicular to what we have in the PQ here one. So in order for us to get the direction of the PQ, so we are actually having like the N, if I actually cross it with the W here, then it actually gives us a vector which is in the direction of the PQ. Okay, so we cross the W and the N here in order for us to actually get vector, okay, which is in the direction of the PQ. So the possible vector that we have in this case is 5, 1, -7. So later on, when we actually want to form the equation of the PQ here, right, that is just, okay, we have got 5, 1, -7 for our direction. And then for the point that the line PQ passes through is we could use the point Q there. So we don't really need to use the point. We don't really need to have any information about the point Q here. Okay, so the for this view, right, for this diagram, right, you can actually think of it as the triangle APQ here is just in front of you. Okay, it's just in front of you. So the N is actually going up. Okay, treat your table as a plane. The APQ is just in front of you, upright, and N is actually going up. W is actually like go towards you. Okay, so you can actually see like what are the reasons that we actually want to do this all the crossing stuff here. So it actually gives us like the direction of the PQ at the end there. Okay, so remember for the vectors, the most important idea that like go through like all the subtopic is that we cross. Okay, so once we cross, we are getting a vector which is perpendicular to both the vectors that we were crossing. Okay, so that is what we need to know, yeah, for the cross product here. Okay, right. So this question, it's basically quite short, but it's also like testing about our understanding like about this cross product thingy. Okay, so it's not really straightforward. Okay, so for the next question here is something that is about like the volume thingy and also a triangle thingy. So we have got 3 points, okay, A, B, C, and their position vectors are A, B, and C. So find A cross B and deduce the area of the triangle OAB. So A cross B, very easy for us to actually find from there. Okay, so what about the area of the triangle OAB here? So basically the area of the triangle OAB here is something like this we have. So to find the area of the triangle, okay, it is just half. So it's a triangle, yeah, so we need to halve it. And then the magnitude of the OA cross OB. We just need 2 sides of the vectors, okay, in the triangle there. So what we have for the OA and the OB is just our vector A and a B that we actually just cross. So basically from what we have in the cross product just now, just find out the magnitude of it and then we divide that by 2. So with that, we can actually able to find the area of this triangle here. Okay, so hence, okay, find the volume of this tetrahedron OABC. So given that the volume of the tetrahedron is 1/3 times area of base times the perpendicular height. So what we need to do in this case is that, okay, we have got a point C. So we already sort of like found about the OAB already, right? So now we have got the tetrahedron, which is like, let's say a point C here. Okay, so this is our point C. So for this point C here, okay, if we actually want to find what is the volume, we need to find the perpendicular height. Okay, so we need to find the perpendicular height here. So for this perpendicular height here, what we need to do is, of course, we are finding the distance from this point C to the plane OAB. Okay, we have got the plane OAB, right? So what we have in the plane OAB is that we can actually find the equation first. So for this plane OAB, okay, we need to have the normal. So this normal is actually our OA cross OB there, then we should be able to get the normal already. And for this plane, it actually passes through the origin. So we will actually have gotten the R dot n is equals to A dot n. So the n is actually our 1, -10, -17, and then the A here is the origin. So that is why we actually have got this is our plane equation. Okay. So later on is we use the point C given. So the point C is 3, -1, -1 to find the distance from the point C to the plane. So distance from the point C to the plane is just we use the distance formula. So it is the x, y, and the z here is to be substituted with the point C there, okay, and divide by the magnitude of the normal. So once we actually do that, we get like 30 over 390, third of a 390. Okay, so with that, we will actually have the volume. So the volume here is 1 over 3 times the area of the triangle as a base there, and then multiply by this perpendicular height here. So which we're actually getting finally, all the values actually cancels off, and we will actually have a very nice volume here. So the volume here is a 5. Okay, so that's how we actually look at the volume for this question here. Right. Okay, so let's look at the next question. Okay, it's quite a long question here, yeah. So we have got, okay, the plane pi 1, okay, has this equation. So we can see this equation given is in the parametric form, okay. So obtain the Cartesian equation of the pi 1 in the form of like px plus qy plus rz is equals to a d. So, okay, what we do here is from the parametric form of the plane, we need to cross the two vectors here. Okay, so these two vectors are parallel to the plane. So we need to cross them in order for us to get the normal of the plane. So we can actually cross them, okay, and we are actually getting a 3, -6, 3, which we can consider using the 1, -2, 1 as a direction of it. Okay, then after that, what we have is, okay, we can start forming the equation of the plane already. So r dot n equals to a dot n. So this is r dot n equals to the a. So this a here is we're using the point. So 214 is a point, dot n. So with this, we're actually getting like this plane equation here for the pi 1. Okay, next. So the plane pi 2 has this equation, which is given in the vector form already. So find the vector equation of the line of intersection of the pi 1 and pi 2. Okay, so it's to find the intersection of the two planes there. So the two planes will intersect at a line, right? So when they intersect at the line, the direction of the line is we cross the two normals from the planes there. So we are actually getting the direction of the line is 3 to 1. So it is just the direction, so we can just take like the simpler multiple of this vector here. It's a 3 to 1. Okay, so after that, what we have is, okay, we want to find a point that two planes passes through. So with this, okay, we just have to try to solve these two equations here simultaneously. Okay, so what we can see from here is we could, we could use different techniques there. We could like eliminate one of the variables, or for myself, I will just like here fix the z is equals to 0 in order for me to actually solve the simultaneous equation. Okay, it's up to you. What is the technique that you want to do? Okay, so at the end, okay, if I let the z is equals to 0, we are able to solve the simultaneous equation to get the x and the y value. So that is where at the end there, I'm actually getting like the x and y and the value of the z here. So this is a point that the line passes through, okay, together with the direction of the line here, right? So the last part of the question here is a 7 marks question. Okay, so the line L, okay, passes through the point A with this position vector and is parallel to this 3c minus 3 plus c. So where A and C are positive constants. So given that the perpendicular distance from A to pi 1 is 15 over sec 6, and the acute angle between the L and the pi 1 is arcsine of the 2 over sec 6, find the values of the A and C. So here it's actually a bit of the simultaneous equation that we do for this question. Okay, it's a 7 mark. So First is look at the perpendicular distance. So this is the distance from a point to a plane, right? So from a point to a plane, the formula is, okay. So for this point here, right? Okay, we can see this point is actually having like the coordinate, which is like a 2a plus 1 and -3. Okay, equation of the plane is actually this one. So to actually get the distance from a point to a plane is that for this plane, we change it into the equals to 0 form first. Okay, we change it into equals to 0 form first. Then for the x, y, z here, we sub in. Okay, so we sub in. So that would be our numerator in our formula there. So for the denominator, it is just the magnitude of our normal of the plane there. So this value should be equals to 15 over 6. So the thing that we need to remember whenever we work with like the this distance thingy, right, is we always have the modulus there. Okay, so make sure that if you actually solve the equations like this, make sure we include the modulus there. So if I actually include the modulus there, we will actually have got like two parts of the solution, in fact. So we actually have like -3, a minus 9 with a modulus is a 15. So we can actually get like values of the a here already. Okay, so we could have a is -8 and a equals to 2. So here it would be a positive 2 because they say like the a must be positive. That's for the first one. Okay, so for the second one is to actually look at the angle between the line and the plane. So angle between the line and the plane is given in the arcsine form, 2 over 6. So it's the same thing that we want to find the angle. So the angle between the line and the plane is we are using the dot product formula. Okay, so this value of the dot product formula will give us the value of the sine theta. So we can actually use the 2 over 6 straight away. Okay, so it's not something different from what we usually do. So it is the dot product divided by each of the magnitude of the two directions there. The first one here is the direction of the line. The second one here is the normal to the plane. Okay, so remember, again, we put the modulus for that. Okay, so as we have got this, we're just trying to solve from there. So we have got the square root. So anyhow, we have to square both sides from there. Okay, so after we actually try to solve it, okay, we have got a quadratic and so on, and we will actually get two values for the c here. It's either a 0 or a 2. So of course here the c is a 2 because again the c here must be a positive value. Okay, so it's quite a bit of work, but it's not really difficult to do, just that it has a lot of work on it. Okay, so let's move on. Okay, so this first plane pi1, okay, has this equation. So find a vector normal to pi1 and hence show that the equation of pi1 can be written as this. Okay, so this is a parametric form of the plane, right? So for the parametric form of the plane, to change it into something that is in Cartesian, we need to find the normal. So the normal is basically we cross the two directions, okay? Or we say the two vectors. So these two vectors are actually parallel to the plane. So we just need to cross them. Okay, so when we cross them, we are actually getting like the -2, -3, -6, which is the normal of it. So when we want to form the Cartesian equation, we use the r dot n is equals to a dot n here. So the n, and this is the a. A here, the 1 to 1, again, it actually comes from the first term here. So this is the point that the plane passes through. Okay, so a dot n here. So finally, we're actually getting like this. Okay, so we can show. So in the next part, we have got another line here. So line L has this equation. So, okay, at the point on L where the t equals to lambda is denoted by P. So find the set of the values of the lambda for which the perpendicular distance of P from pi1 is not greater than 4. So this is to look at the distance from this point P to the plane. Okay, distance from the P to the plane. So this is a distance from a point to a plane. So what is this point here? This point is actually when we have got the t is equal to lambda. So basically, you just sub the lambda in. So for the coordinate for the P here would be something in terms of the lambda there. So we can find the distance. So the plane is given in this form, right? So we just have to substitute the x, y, z into the equation of the plane there, divide by the magnitude of the plane. So because here they actually want the distance, which is less than or equals to 4. So we have got less than or equals to a 4. But whenever we want to find the distance, we always have to include the modulus here. So once we actually try to simplify everything from there, it gives us quite a nice result there. So it gives us like the modulus of a 56 lambda plus 28 is less than or equals to 28. So in which we're actually able to solve the inequality, okay, from our concept from the modulus there. In order for us to get this, the lambda is from -1 to 0. Okay, so that is how we do the second part here. The third part, okay, is the plane pi2 contains the L and the point with the position vector, which is 1 to 1. Find the acute angle between the pi1 and the pi2. Okay, so in order for us to find the acute angle between the pi1 and the pi2 is we need to find the normal, okay, the normal of the pi2 here. So to find the normal of the pi2 here, it actually has given us like this information here. So we need to find the pi2, the normal for the pi2 here. So basically what we see here is the pi2, right? Okay, this pi2 is actually like having the point which it passed through 1 to 1 and it contains the L. So when it contains the L, it means that, okay, this is, let's say, our L here, right? So this L actually passes through 382 and then the direction of it is like a 465. Okay, so that's what we actually get. So if we want to find the normal of this plane here, it is we need to have two parallel vectors. Okay, so two vectors which are parallel to the plane here. So first, we can actually use a 465. So another one is we can actually use this vector here. So we can use one point minus the other point here in order for us to get another vector, which we can actually cross them. Then later on, we're actually getting the normal for the plane 2 there. Okay, so the next step is, okay, minus the 2 points. And then this is another vectors, which is parallel to the plane there. So we can actually cross the two vectors here and get some direction for the normal there. So it's N2, it says 4, -1, -2. So then later on, we can just use the dot product formula to actually find the angle in between the two planes there. Okay, so the angle in between the two planes is the same as the angle between the two normal for the planes, yeah. Okay, so that's how we do this question here. Okay, so if we continue to look at the next question here. So this is a 40 marks question in total. Okay, so we have got 4 points here. Okay, it is given that the shortest distance between the line AB and the line CD is 3. So we need to show that we have got this quadratic involving the lambda here. So it's not difficult at all. It's just a lot of work. Okay, basically this is to look at the shortest distance. So for the shortest distance that we have here is we have to find like it's a line AB and a CD, right? So we need to actually like find out like the direction of the line AB, which we can consider using the AB here, and we can consider to use like the CD here, okay, for the direction of the line CD. So we can minus. So something would be in terms of like the lambda there. So later on, that is we have got the cross, like the AB cross CD. So this is a direction. We cross them together, and we are getting something which is in terms of the lambda as well. Okay, so we have got, this is a formula, right? Okay, this is the formula, right? So we actually have like, so let's say this is our B1, this is our B2. So this is our B1 cross B2. Okay, so you just look at the directions of the line AB and the line CD. So for this OC minus OA is actually we have like the A2 minus the A1 from there. Okay, so after that is to look at the distance now. So the distance is actually equals to 3. So we remember we have to put in a modulus there. So now it's about doing all sorts of the working. So the numerator there is to dot. And then for the denominator there is to find the magnitude of the AB cross CD there. So once we actually finish it, we can actually have something like this, which is quite nice. Okay, so if you actually try to square both sides, okay, and we try to simplify from there, it should be able to give us this quadratic relationship here about the lambda. Okay, so that's for our first part of the question. So what we have in the second part of the question is that, okay, we have got find the acute angle between the planes, okay, through ABD corresponding to the values of the lambda satisfying the equation in part 1. So basically from part 1 there, okay, we will have two values of the lambda. We can solve it. We can get two values of the lambda. So with different values of the lambda there, right, we will get different values for the plane, which is like plane which passes through the ABD. Okay. So we have got like the two values of the lambda here is 1 and 4. So for this value of the 1 and 4 here, we need to find the normal of the plane ABD. So we can use like AB and an AD there, and we can cross them to actually get the normal. Okay, so they say they want to find the acute angle between the two planes there. So we find the normal for the first plane, then we repeat the same process, okay, in order for us to find the normal of the second plane there. So it's to find the acute angle between the two planes here. So it will be finding the acute angle between the two normal. So the acute angle between the two normal is just we use the dot product formula again, right? So once we actually try to work it out, then this is the value of the data that we'll be getting, which is get like a 12.1 for that. Okay, so that's what we have for this question here. Okay, so there's another question here, the last question. Okay, so for this, with O as the origin, we have got the point ABC. So find a vector equation of the common perpendicular to the lines AB and OC. So, okay, what is actually this question means, yeah, is, okay, we have got a line which passes through the A and B, right? And let's say we have got another line which passes through the O and the C. So they want us to find the common perpendicular. So the common perpendicular here is like, okay, we need to have this line here, okay, which we want to find the equation of it. So it's perpendicular to the AB and OC at the same time. Okay, so we need to find the direction of this line first. Okay, so for AB, okay, we can use the OB minus OA, that we can actually find the line AB. And for the OC, okay, the direction is just the C itself. Okay, the direction of the line OC is the direction, is the OC itself lah. Okay, because it's passed through the origin, so this is the direction. 112, it will become the equation. So we have got S, 112, and then the point that it passes through is actually like an origin. So we don't need to write the point there. So now, okay, we want to find the direction of the line. So the common perpendicular line is we cross the two normals there. Okay, because it has to perpendicular to both the AB and OC at the same time here. So we cross them. So this is what we get. Okay, so next is we have got the common perpendicular already. So it must actually pass through like some points here. So now we are trying to find what are the points that we have for that. Okay, so we could consider, okay, let's say P is the point on the first line, Q is the point on the second line. That is, the PQ here is perpendicular to both the lines there. So we could first find what is the PQ. Okay, so P is this point because it will just take the equation of the first line. Q is having this coordinate because it is taking the equation of the second line. Okay, we don't know what are the points yet, but we could think of, okay, we don't know what is a point, so we just take the the equations of the lines first as the coordinate of the P and the Q. So later on, we find out what is a PQ, and we know that this PQ should be perpendicular to both the directions of the line. So when we say about the perpendicular, we need to dot, and we will actually get a 0 from that. So same goes to the second one here. So we dot, and then we get 0, and then from here we can actually get some values for the S and the T by solving these two equations here. Okay, so with with the values of the S and T that we get just now, okay, so we need to have like one point, right, in order for us to actually get like the equation of the line. So let's say we take the point P, which is 1, 0.20, then the common perpendicular to that two lines will be this. Okay, the point plus the direction. Okay, So part 2, show that the shortest distance between the lines AB and OC is 2 sub 5 over 5. Okay, so the shortest distance between the line AB and the OC, right? Just now what we did was we actually let it to be like the PQ there. So for the PQ, we already have got what is the vector of it. So we just have to sub in the S and T that we found just now. Okay, and then we just need to find the length of it. So the length of the vector PQ here is the shortest distance between the two lines there. So this is to use what we have actually found in the earlier part there. Okay. So in the next one, okay, is find in the form of like ax plus by plus cz equals to d, the equation of the plane which contains AB and the common perpendicular of the lines are AB and the OC. So basically it is like this line here, the common perpendicular is in the plane. Okay, it's in a plane. So this plane also has got like the AB. So basically this is AB and then this side is actually in the plane. Okay, so to find the normal of the plane, it is by using the direction of the AB and also the direction of our common perpendicular. So you can actually get some normal for that, which is 102. And what we know about that is that, okay, we can use the R dot N equals to A dot N in that case. The N is, of course, the 102 that we have just found. And then the point A here, okay, this point A here is basically our point that the plane passes through. So the plane passes through quite a lot of points there. It passes through point A, point B. Or it could also like pass through the P and the Q as well. So let's say we use the point A is the easiest, which is just 100. So we just put it, okay, the 100 there. So from there, we are actually getting this is the equation of the plane. All right.